The scale shows a vertical tower BT and a flagpole TP mounted on it. It says a point R is on the same horizontal ground and is such that RB is 60 meters. So RB is 60 meters. Just putting that out there. RB is 60 meters. And then it says now, and the angles of elevation of T and P from R are 35 and 42. So the angle of elevation are 35 and 42. All right, so it's a label to show the distance 60. There it is. The angle is 35 here, the 42 here, and any right angle. The right angle is here. And then it says now, calculate the length of the flagpole. What's the flagpole? The flagpole is TP. So I want to calculate this length. So first and foremost, the length of the flagpole TP is equal to BP. We can find the length of BP and then subtract the length of BT. All right. So we need to find BP first and then BT. So let's do that. To find the length of BP, now cos theta, which is cos 35, is adjacent. Well, let's not use cos. Since it has to deal with opposite and adjacent, let's use tan. So what am I saying? I'm saying that the tan of 35 degrees is equal to the adjacent of 60. It's equal to the adjacent of 60 tan theta is opposite over adjacent. So it's BT over 60. BT over 60. That's tan 35. All right. And also, the tan of 42 is going to be equal to BP over 60. So that means we know the length of TP clearly. So what is TP? TP is equal to 60 in bracket tan 42 minus tan 35. So this is the length of the flagpole. Length of the flagpole is 60 tan 42. That would be BP minus 60 tan 35. That's equal to 60 tan 42 minus 60 tan 35. That's 12 meters. That's 12 meters. That's the length of the flagpole. Part B. So unfortunately, this year they don't give any bearings. They don't give any circle theory. So this is just straight to bearings. It says a diagram below, not drawn to scale, shows the relative positions of three finishing bolts, K, L, and M. L is on a bearing of 40 degrees from K. L is on a bearing 40 degrees from K. So here's the from position. So here is 40 degrees. All right. And then it says that, and M is due south of L. And M is due south of L. So they're telling us that this is 90 degrees. All right. So they're telling us that M is due south of L. South is 90 degrees. And they tell us LM is 120 and KL is 80. This clearly is 90. All right. Now it says calculate the measure of angle. Well, show the bearing 40 degrees, which we did. And then it says calculate the measure of angle KLM. So let's work out KLM. Now I like to set up my right angle triangle. I know that right here would be 90. So what does that leave for me? That's telling me that this inside angle is 50 degrees. This inside angle is 50 degrees, and this angle out here is 90. What does that leave for me then? If this outside here is 50, and this outside here is 90, angles on a straight line is 180, and so in here is also going to be 40 degrees. This is also going to be 40 degrees. All right, and so angle KLM equal 40 degrees. Clearly. Then it says work out the length to the nearest kilometer of KM. Now when you have two sides and an angle between those two sides, you use what is known as cosine rule. So let's use cosine rule. Cosine rule will tell us that Km squared, cosine rule will tell us that Km squared is equal to 80 squared plus 120 squared minus 2 times 80 times 120, 2 times 80 times 120 times the cosine of 40. And that's Km squared. So convert that out now. So we have 80 squared plus 120 squared minus 2 times 80 times 120 times the cos of 40. Now, and so Km squared is equal to 6,091.9 kilometers. All right, that's Km squared, but we need Km, so we have to square root both sides to see that Km is equal to the square root of this right here. So Km is the square root of 6,091.9. Km is the square root of this, and the square root of that is going to be 6,091.9 square rooted is 78. And so Km is 78 kilometers. Km is 78 kilometers. That's crazy. Km and Km. That's crazy. Nice. So this is a nice question. Finally, it asks for angle LKM. LKM. angle LKM. Now what I'm going to do is I'm going to use sine rule. I just like to stick with sine rule. With sine rule, I know this angle right here corresponds to this side. And so the sine of 40, using sine rule, the sine of 40 is equal to sine of 40 over this km 78 is equal to, now we want to find this angle. It says LKM, so call it theta. It's going to be equal to sine theta over 120. So what is theta going to equal to make this true using sine rule? All right, so theta is going to be equal to sine inverse 120 sine 40 over 78. All right, so this angle right here is going to be equal to 120 sine inverse 120 sine 40 over 78. When you work that out, what is that equal to? 120 sine 40 divided by 78 sine inverse getting 81 degrees. So I'm getting that angle is 81 degrees. I'm getting 81 degrees for theta right here. All right, theta is 81. Nice. Now, what's the final thing they're asking for? They're asking for the bearing of M from K. The bearing of M from K. So let's work out that now. The bearing of M from K. It's from K. The bearing of M, wait. The bearing of M from K is going to be, I'm going to put it in black, all of this angle. So this is 40 plus theta 81. So the bearing of M plus K is 40 plus 81. That was easy. So the bearing of M plus K, bearing of M from K is the 40 degrees plus the 81 degrees. And that's equal to 121 degrees.